All right, this is a quick video of section 2.3. All right, so now let's kind of recap real quick. All right, we started out with linear functions, defining what they were, slope, intercepts, zeros, etc., etc. I guess Monday we actually did some modeling with linear functions or data sets. Really, that's what it was based off of, and we approximated the models, or found models to represent the data, or regression lines to actually represent the data. So today, basically, we've kind of seen this before. We're going to deal with what's called systems of linear equations and two variables. And basically, now a system of linear equation is exactly what this definition says. It's a collection, okay? A collection, all right, of linear equations containing the same set of variables. Now that can be two equations, three equations, four equations. You can have really a infinite number of equations within your system. Okay, now for our purposes today, we're trying to find a solution to a system and two variables, and we're looking for an ordered pair that satisfies both sets of equations. Okay, so here's an example. Okay, now typically you see this brace, right? It's on the left. Typically you'll see the brace over here, and that symbol simply indicates that, hey, you're dealing with a system of linear equations, so your answer will be an ordered pair, right? And depending on the subject, you could call it a vector, you know, in an advanced math class. But your answer would be something like x comma y, okay? And whatever that point is, or those points are, they satisfy both of those equations. All right, so that's your system, or an example of a system. Our answer will be in the form x comma y or s comma t, but we're going to have a pair of solutions because we got two variables. All right, so now graphically, you've got three choices, okay, or three options, I guess, in terms of solutions. You can have a unique solution where you've got one intersecting point. So let's say it's right here, right? That's our intersection. Okay, you've got no solution. All right, the lines are parallel. You'll call the system inconsistent because you can't find a solution. And then you have what's called an infinite set of solutions where essentially the lines are, or then it's not essentially, they are the same line. The equations look different, but when you can either factor it out, or however you want to do it, the lines are exactly the same. You've got a dependent system, but infinite solutions. So any ordered pair, all right, within that domain will satisfy will satisfy both equations in your system. All right, so now how do we go about solving? Three options. Okay, the one I'm probably going to say is probably, well, it depends. It's going to vary. It's going to vary. So option one, you can graph, right? You graph both lines. You see where they intersect. And remember, that intersection is going to typically be an x comma y, right? That's your solution. You can substitute, which is a little bit more intensive in some cases. You solve for one equation, or for one variable in one equation. You take that variable and you substitute into the other equation, do a little bit of algebra. You find either x or y, or your first or second variable, get a solution. Then you back substitute. Okay, it's a little bit more complex, but you've got a couple steps. All right, so it's step heavy. All right, then elimination is probably you kind of doing it at this. You're solving both of the equation at the same time, but you're trying to eliminate one variable. So we're going to demonstrate, or I'm going to demonstrate, how to actually solve a system using all three techniques. Okay, so let's jump into, maybe these are some steps. All right, so substitution, I'm not going to go through all the steps. All right, you solve for one variable, and I kind of said that you substitute you substitute for what variable you solved it into your other equation. You solve for that remaining variable, and then you essentially back substitute and find your second variable. Okay, so that's substitution method. Right, steps for elimination, same thing. You're trying to get the equations to be equivalent so you can cancel out a variable. And again, I'm not going to read all that to you. Just if you need to, hit pause, read the steps, and you'll be fine. All right, so let's do this one. Now it says solve the system by substitution. We're not actually going to solve by substitution. We're going to solve by graphing. Okay, graphing. All right, so what we're going to do, we're going to pop up our app, and I actually need to see the equation. So let's drag that here. All right, so my first line, I've got 3x plus 4y equals 10. All right, my second equation is 4x minus 2y equals 6. All right, and there it is. Okay, so now notice, now let me go ahead and zoom over. All right, so there it is, where these lines intersect. Okay, now notice I didn't do any work, other than plotting the two lines. Okay, now they didn't say use slope intercept form or use the intercepts or use point. They didn't give me. They said, hey, find the solution. Okay, so y'all know I'm real tech heavy, so I'm like, use your tools. So now our intersection is right there. Okay, so I look at that. I need my x coordinate is 2. My corresponding y coordinate is 1. Okay, so I'm gonna go up. Let's go back to my app or the notes. So our solution, right? We're gonna write our solution as, it was 2, 1. All right, so that's your solution. It has a unique solution. Okay, didn't require anything. Now, first method, real simple. All right, now we're just gonna extend it. So we kind of know that's our solution. Let's check it. Let me show you how to check it, and then I'll start another video for this solving by substitution. So let's check this. So we know that we're going to take 3 times 2 plus 4 times 1, and we're going to say, hey, does that actually equal 10? And guess what? That's 6 plus 4, which is indeed 10. Now, this is where I say you got to kind of be careful with the graphing. Okay? So now, just because that solution satisfies that first equation, remember, you got to substitute into the original when you check your work. Okay, we're fine, but we need to check. So that one was cool. So now we're going to say, okay, does 4 times 2 minus 2 times 1 equal, we put the little question mark on top of the equal sign just to verify. Okay, that's saying, is this true? Okay, is it equal to 6? So that's 8 minus 2. Is that equal to 6? And indeed, that is. 6 equals 6. So guess what? That solution is golden. Okay, so that's via graphing. All right, so now next we're gonna extend this, and we're gonna use substitution method. Okay, now substitution method, like I said, it's a little bit more intensive in terms of the algebra that you have to do, but nonetheless, we can still solve. But now you've got to make a decision here. And you say, okay, which one of those equations looks the cleanest, or come out, without any fractional terms? So 3x, 4y, and 10, I know, okay, no multiples of 2. I've got a 3 in there. It's a prime number, so I'm not going to mess with that one. So what I'm going to do is I'm going to take this equation, this 4x minus 2y 6. What I'm going to do on both sides, y 6 minus 4x. All right, we're going to do 2. Now be careful here. And we end up with y equals negative 3 plus 2x. Okay? Now, we're going to just, that's what we're going to substitute into the first equation in the system. So what we're going to do, we're going to come to our equation, and we're going to keep the 3x. We're going to keep that 4, and we're going to keep that 10. All right, now, y is equal to, so this is why it's called substitution. We know y is equal to negative 3 plus 2x. Alright, so then what you do is you gotta do a little bit of algebra. You substitute it. This becomes 3x minus 12 plus 8x equals 10. Alright, continue to take your time. And we end up with, let's clean that up. We end up with 11x minus 12 equals 10. Okay, we just combine like terms on the left side of the screen. Alright, we're going to add 12 to both sides. And we end up with 11x equals 22. Last step, divide by 11, x is 2. Okay, so now we already know our solution is 2, 1, right? We know that. All right, so we've got x equals 2. Okay, cool. Now what we're going to do, we're going to substitute. So we already have this equation down here, right? We already got this equation, y equals negative 3 plus 2 times x. Okay, so we're going to come over there, and we're going to, all we're going to do is keep the y. Boom. Going to keep that negative 3 plus 2 times 2, which is negative 3 plus 4, which is indeed 1. So y equals 1. And guess what? We've just solved that system via substitution. Real simple. Just take your time and work your way through the algebra. But again, if you look at the techniques and say, well, what's easier, graphing or substitution? Obviously, the graphing was the simplest. It didn't require anything. It required you using your utility. You know, we didn't have to do anything with the window. You know, it came out pretty clean with the graph, so we were good. Okay, so now we did graphing, we did substitution. Third technique, elimination. Okay, so same problem. We know the solution. So let's say we want our solution to be, we already know, not that we want it to be, we want to confirm. All right, that 2, 1 is indeed the solution. All right, you've got your system. They'll give you the little brace out there. All right, so now you've got to look. You say, do I want to get rid of x? Do I want to get rid of y? So I'm looking and I'm like, okay, I want to get rid of this y. Okay, so I've got 4y in the first equation. I've got a negative 2y in the second equation. So I'm trying to get rid of that 4y. So I said, okay, in order for me to get a 0, 4 minus 4 is indeed 0. So what we're going to do, we need this bottom equation to go to 4. So we're going to multiply everything by 2. in that second equation. So you keep your first equation, 3x plus 4 equals 10. All right, your second equation, we're going to multiply or distribute. Well, I guess you say multiply everything in that second equation by 2. So this becomes 8x minus 4y equals 12. All right, draw yourself a line. We're going to add these guys together because we're trying to get a 0. The positive 4y minus 4y, that goes to 0. 3x plus 8x is 11x. 10 plus 12 is 22. We divide by 11, right? X is indeed 2. Okay, no problem. Boom. All right, so notice that technique was a little bit faster than the substitution technique. But note, now you don't do this again for the y. You already know what x is, so you take one of your original equations. So I'm going to take that first equation, and I know that 3 times x plus 4 times y equals 10. Now we just solved for x. We know x is 2. So we substitute that into one of the original equations, and we end up with 6 plus 4y equals 10. Subtract 6 from both sides of the equation. Let's draw a little squiggly line here. And that's 4y equals 4. Divide by 4. Divide by 4. Y is indeed 1. Boom. So that's solving systems of linear equations using 3 techniques. And let's scroll back. All right, we started out with graphing, right? And we got it real quick, okay? Found the intersection, no problem. Use substitution, a little bit more work. Elimination, still a little bit of algebra, but not as bad. Okay, so I'm going to pause it here and then we'll come back and get these applications.